And really, it's kind of the same for kids, too. Now, though, we're going to get a look at our meteorologist, Anthony Yanez, and what he's up to during his school visit.
Yeah, Anthony's joining us live this morning from Cyfair ISD's Willbern Elementary School for his weekly weather lab. Anthony, as you know, this is one of our favorite moments of the week.
We love to see how you interact with those students, and we know the students are excited.
Good morning. I am at Willbern Elementary School in Cyfair ISD. I have some very special 3rd, 4th, and 5th graders to introduce you to. Are you ready to see them? Can you guys give our audience a big hello? They look great. So I know a lot of you guys aren't aware of this, but this week it's called Severe Weather Awareness Week, and the National Weather Service puts that out once a year so people are aware of the kind of weather that we get here. And so today, because it's a Wednesday, today is Tornado Safety Day. So I'm going to talk about tornadoes. So let's start with, first of all, tornado safety. There's a tornado, there's your house. And what do you do when it happens? First of all, for my job as a meteorologist, the way I track tornadoes, the way I see tornadoes, one of the questions was, why is a hurricane eye, why is it called the eye? Well, with a tornado, we use the radar to be able to see what's going on with storms. And many times with radar, we can see a tornado. So first of all, I need somebody to help me here. I needed someone. Come on up. Come on up.
Is that a glitter bomb?
It's not, but it's an example. What's your name?
Carter.
Carter, everybody say hi to Carter.
Hi, Carter.
Carter, you're going to hold that, okay? So, Carter is holding out a blue ball. I am going to be this radar beam off to the side. So what radar does is it goes around and it is sending out signals, and every time it goes around, it goes higher and higher in the sky. Do you see how my arm is going up?
Yes.
And then it comes back down. So radar's always doing that. It's doing that whether there are storms or whether there's not storms. It's going up and down. So as the beam goes out, Carter, who has the ball, the radar beam is hitting the ball. Once it hits something, because there's nothing over here, once it hits something, it is sending, you see the red color? It is sending a signal back to me as the radar and telling me you're hitting something that's normally not there. Because, put the ball away, if there was no storms, if there was no rain and I ran around, I wouldn't see anything. But Carter puts out the ball. Let's just say it's a raindrop. I'm hitting a raindrop now. Radar does something else too. It's called what's called dual polarization. That's a big word. All you need to know is not only does radar go out like this, it goes up and down like this. So now when it's coming over to Carter, who's holding this, it is telling me not only is it hitting something, it's telling me it's this big. And when something's this big, does that look like a raindrop to you?
No.
What does that look like? Hail. It's telling me that there's hail out there. So good job, Carter. Carter just demonstrated how radar sees hail. But how do we see a tornado? First of all, when a radar is going around and it's looking for things, it's looking for what are called hydrometers, like a water drop or a ball of ice, like with hail. But it's also looking at winds. And so what you have with the radar, red, the color red, are winds that are moving toward the radar. Green is moving away from the radar. Do you see where the red and the green are matching up? They're matching up in two areas I've circled. And where it's matching, where it's coming together, that's called a hook echo. So understand that it's looking at winds also. So what I'm telling you today is kind of like really advanced stuff, but I know you're really smart 3rd and 4th graders and 5th graders. So I'm showing you this before I actually show you the tornado. It also looks at what's called correlation coefficient. It shows debris flying in the sky. So what Carter showed was something that looked like hail, right? But what if it's a brick? What if it's a tree? What if it's a branch? Well, now what it's doing, do you see, look off to the right here, that blue spark? Correlation coefficient is telling me you're now looking at things that shouldn't be in the sky. Rain can be in the sky, hail can be in the sky, but now you're looking at something even more powerful, and that's correlation coefficient. Deer Park, almost a year ago, in January, a little more than a year ago, Deer Park got hit with a really strong tornado. Do you see that shed that's up in the tree? Yes. That shed on radar will look out of place and will tell me, not only do I have a hook and the wind's coming together, but it will tell me, hey, you've got a tornado because you're seeing something in the sky that's huge that shouldn't be there, like a shed. Do you see that what used to be an apartment complex? There are trees, there are branches, there are bricks. All that stuff got thrown around. Radar sees all of that. And then do you see the car off to the side? It got just trashed. It wasn't driven there. That was moved there by 140 mile per hour winds. So correlation coefficient picks all of that up. So January 24, 2003, this was a tornado outbreak that featured 5 different tornadoes. This one was an EF3 with 140 mile per hour winds. It was 1,000 yards wide, so it was as big as 10 football fields. It started in Pearland, went through Pasadena and Deer Park, and it ended in Baytown. So this is one of the only videos that actually exist of the tornado on the ground. First of all, it's really tough to see because there was a lot of rain around, so it was called what's rain-wrapped tornado. So it doesn't look like a classic tornado, but there it is on the ground. And what is he trying to do while he's driving? Get the video. So incredible that he got that. But dangerous also at the same time. How powerful are winds in a tornado? It knocked over a train on its tracks. Could you imagine if we got all of us together and pushed on a train, together and push on a train and it wouldn't budge? What are you seeing with the train? Is the train up or is the train down? How powerful are winds from a tornado?
Looks like a tornado wind and budges.
Yes. Now, let's see if this works. Okay, this is a video that shows the tornado going through. So first of all, remember how I was mentioning it's what's called rain-wrapped. Many times with tornadoes, you don't get rain around it, but this time you're getting rain. What I want you to notice with this tornado is the way the wind shifts and how you can tell when the tornado is hitting this building. So look at the flags going out. The wind is going out. It's raining heavy. It gets heavier. Tell me if you can say, everyone say, I see it when you see the tornado go through.
I see it.
I don't see it yet. So how powerful are the winds? It's knocking everything off that roof. And do you see, besides everything moving, now the water's coming down, it's not like you're seeing anything classic twisting. More roof coming down. Watch how, now tell me when you can, if you see, tell me when you see it, when the tornado moves away. It'll be happening here shortly. There's more stuff coming down? Yeah, good job. Did you saw the winds calm? Look at the flags going out now a different direction. Good job. You guys are really, really smart. So where to hide in a tornado? Tornadoes are a good lesson in how to stay safe, because if we had severe weather right now, we're in a bad spot. We're in a big open area. So when this roof falls, we're in a bad spot. We have windows here. For those twisting winds, it's picking up rocks, it's picking up bricks. We're in a bad spot. So for a tornado, you're safer every other place when you do your tornado drills. This is a bad place. So you want to go into the most interior room as possible in your house, a hallway, a bathroom. We don't have basements, but you want to put as many walls between you as possible. Looking outside is really bad. So just an important thing to know. At home, go into a hallway, small room, away from windows. Bathrooms are good. At school, do what your teacher says and stay calm. That's the most important lesson. When I first got here in 2003, speaking of 2003, There was a tornado that went through a school in Sugar Land. It went right through the school. Bricks, glass were everywhere. And when I interviewed the principal told me only 2 people were hurt, and it was minor. And it was 2 people who, they covered their heads, and they got hit with glass, and one got hit by a part of a brick. So they had some scratches and cuts on their arms. One needed stitches, but it wasn't anything dramatic. But I'm looking around, and I said, how did nothing bad happen here with these kids? And they say, I tell you what, Anthony, the kids were great. The teachers were great. The teachers knew what to do, and the kids listened. Nobody was panicking, going, oh my gosh, I'm going to die! Ah! Everybody listened and was calm. So that's important if that ever happens here. Here's some of the images of what we get with tornadoes. This is in Kingwood, and again, January 2022, the year before. We get most of our tornadoes in the winter where we live. We get EF0s and EF1s, which are 65 to 109 mile per hour winds. Again, when you look at the tornadoes in these images, they're not really big monsters. The one last year was large, 10 football fields. Most aren't that big that we get here. So how do tornadoes form? This is the #1 question. Whenever I go out to kid visits or school visits, they ask this question. So first of all, it starts with a cloud that looks like this, a cumulonimbus cloud. So I need someone to help me with this. Let's get right in the front. Come on up. This is just a simple illustration here. So what's your name?
Lily.
Lily. This is Lily. Everybody say hi to Lily. Hi. If Lily was a cumulonimbus cloud, there's parts of where the storm is. So looking at this, where Lily is, Lily's a storm that moves like this. You get heavy rain and hail, Carter. All that's right here. It's dry right here. The tornado is here. Clouds are back here. So that's typically what you have. So the reason you see a lot of good tornado video is because it's not where the rain is. It's not where the hail is. It's back here. Now, it's not always the case, like last year's wasn't that way, but it usually is. Good job. Good job, Lily. Thank you for helping us out with that. Let's see. So how do we get there? So first of all, to get rain, and you guys might get a little rain, light rain tomorrow evening. You're going to get rain Friday. To get rain, you need moisture and lift. So on a day like today, we're going to be dry because we've got high pressure around that sinks the air. It's tough to get rain. But if you have moisture like we have right now, a lot of fog, and you get lift, you get rain. Now, to get thunderstorms, you need moisture, lift, and instability. So you need moisture, you need lift, and now the atmosphere needs to be out of balance. And when the atmosphere is out of balance, it will create lightning. But to get tornadoes, you need moisture, lift, instability, and now wind shear. Wind shear is a changing of winds with height. So instead of going straight up, the wind's going straight up with an updraft. So I'm going to give you an example of winds. Here are straight line winds. Straight, boom. You can feel that, right? It doesn't hurt, but you can feel it. Straight. Updrafts to get hail are powerful. Those go straight up. But to get tornadoes, you now need the wind to twist. Here's another example of this. Wind shear is a change of wind speed with height. So what you have on the ground is you have, watch my feet, you have the winds go like this, and above it you have the winds go like that. Do you see the change in wind direction? It's like a football. I need 6 people to help me. So I need 2 3rd graders, 2 4th graders, 2 5th graders. So you two, and then you two. Come on up. Really quick. So, oh, we got Carter again. Okay, so I'm going to have you come here, Carter. Come here. Face me. Carter, you're taller. Okay, you right here. You right here. Where are my 5th graders? So tornadoes are like football. Who plays football? Who's thrown a football? Then you're familiar with this. Come on over. You get in the back. Let me see where you are. How tall are you? Okay, face me. Put your hands up. because you're all, well, you know what? Are you taller? Carter, let's switch places because we need to put your hands up. What's happening is with this updraft, I'm going to give you the football. You're going to spin it and put it to the person behind you. Take it, spin it, put it, spin it. Good. Do you see, with their change in height, how it's spinning and it's climbing? Big arms from where it started, and now as it goes up into the sky, it creates a wall cloud, and then it comes down as a tornado. We'll show you that one more time. Oops, fumble. All right. Ready? You're going to catch it this time. Ready? Here's the spin on the ground. Go up, spin. It climbs. The winds, the updraft is moving it higher and higher and higher to eventually it's climbing, and then it comes down over here as a tornado. Good job, you guys. That was great. That was good. Now let's talk about thunderstorms. I want to make sure we leave time so we get our forecast done. First of all, if you hear thunder, get inside right away. The safest place to be is in your home, school, or car. This is a bad place for a tornado. This is a good place for lightning strikes. Because if lightning hits the building, it goes on the outside, you're fine. We're good here. It's going to be scary. It's going to be really loud. It's going to be really bright. But we're safe because the electricity can't get in here. Here's a shot of lightning coming down in slow motion. How lightning forms. On a day like Friday, we might start, well, not this time of year because we have fog, but in the summertime, start with clear skies. The sun heats the ground. Clouds start to build up. They condense. They get bigger and bigger. Remember the instability. It needs to be cold up on top. And then thunderstorms form. There's your cumulonimbus cloud. You get rain, you get lightning. It's like a battery. So all our batteries that we have at home have a positive and negative. The atmosphere does not like being out of balance. So as I was showing you with lifting my leg, I could stand here all day because I'm in balance. I would get hungry, I would get tired, but I could stand here all day. But once I lift my leg and I'm out of balance, that's a negative, that's an imbalance. So negative, positive, negative, or positive, negative, positive. So what you have is an imbalance in the atmosphere, and that's what creates lightning. And so on thunderstorm days, or when there's lightning that you hear, or thunder, excuse me, lightning that you see or thunder that you hear, do not be outside. What happens to this kid? He got hit by lightning because he's outside. Never stand under tall trees. The most dangerous place to be in a thunderstorm is under trees. Most people are like me because they don't like getting wet. So when there's a big heavy rain and thunderstorms, they go under trees to stay dry. But lightning usually hits the tallest thing out there, and that's the most dangerous place to be. And it's not only if you're touching the tree. Look at how the electricity that's hitting this tree is fanning out. So if lightning hit me right here, the electricity could go out to you, to you, to you, back here, back here, back here. So get away from those trees. More important, don't be outside, be inside, right? Does everyone get that? Okay. Here's the question. Is it safe inside your car? Yes or no? No. Yes. So you'll learn this probably in mid-school science, maybe high school. Metal acts as a Faraday cage when you're inside it. So lightning will hit the car. The metal protects you. The lightning, the electricity will go outside the car. It will go through the tires. It's not the rubber tires that protect you. It goes through the tires and into the ground. So just like lightning hitting the building, it goes on the outside, goes into the ground. It hits the car and goes outside. It's going to be scary. It's really loud. It's bright. I had a friend of mine whose car got hit by lightning when he was driving, and it trashed his radio system, but they were all fine. In fact, the car was okay. It was just the electrical components for the radio that went bad. So pretty strange. But you're safe inside a car. So if there's ever thunderstorms and you're outside, it's safe to be in a car. It's better to be inside. It's the worst to be outside. Okay, we'll end with a couple questions and then we'll do your forecast. How far away is lightning? So there's your lightning strike. It takes 10 seconds to hear thunder. So 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000, 6, 1,000, 7, 1,000, 8, 1,000, 9, 1,000, 10, 1,000. Boom! There's your thunder. How far away is that lightning strike? You can raise your hand. Let's do, let's see, I picked a, yes, real loud, yes. Really loud. How far away is it? 500 miles away, okay. Yes, how far away is it? 10,000 miles away, yes. 10 miles away. So every mile is 1 second, okay? So your answer is every 5 seconds is 1 mile. So with knowing math, if 5 seconds is 1 mile, how far away is that lightning strike? Oh my gosh, you guys are so smart. That's great. 2 miles away, but it took 10 seconds for you to hear that. And that lightning strike for 2 miles is close. So if you see lightning or you hear thunder, get inside, because it might be 20 seconds. And you're like, oh, that's far away. 4 miles? That's close. Okay, next question. Here's another lightning strike. How big is lightning? So I'm talking width, not sky to ground. Could you hug it? Is it as big as this room? Is it small? Let's get some more guesses here. Raise your hand. Yes.
I think it's about 22. Yeah, I think it's about 22.
22 miles. So that lightning strike basically comes, when it hits, it's hitting here all the way to my TV station. So it's massive. So that's one guess, 22 miles. Let's go more in the back. Yes. How wide is a lightning strike? We got one guess, 22 miles. Yes. 12 miles, so half of that. So half the way from here to like downtown. Yes. How wide is lightning? Right here. Yep. 6 miles? Oh, you want to give your answer? Okay, go ahead. Go ahead. Go ahead.
Whenever lightning stops a electric car while being drive.
I'll get to that in a little bit. Okay, so how big is lightning? 3/4 of an inch.
What?
If lightning hit and you were Flash, you could catch it and it would fit in your hand like this. Lightning is tiny, but it's powerful. So be inside whenever there's thunderstorms. Okay, well, let's see. All right, I'm going to skip this. Lightning goes up and down, so it doesn't always just come from the sky to the ground. Sometimes it comes from the ground up also. How hot is lightning? On a day like today, it's 84 degrees outside. It's 94 inside this cafeteria. The sun is 10,000 degrees. Lightning is 50,000 degrees. 5 times as hot as the surface of the sun. How I forecast the weather? I talked about radar, satellites, recording stations. I have surface maps. I look at weather models, so I go to school for that. And I also look outside. So if the rock is wet, it's raining. If the rock is swaying, it's windy. If the rock is hot, it's if the rock is hot, it's sunny. If the rock is cool, it's overcast. If the rock is white, it's snowing. If the rock is blue, it's cold. If the rock is gone, tornado. And then I make the graphics. And this is how I do my job. Sometimes I'm in front of a green screen. In front of a green screen, the one thing that 3 of your students will notice when they do this, because they haven't seen themselves yet, if you brush your teeth at home in front of your mirror, the toothbrush is aligned. If you brush your teeth on TV, the toothbrush is over here. So it's now your turn. Come on up. We have 3 classmates. Who's first? William? We have William who's going to come up. William, you're going to give the weather for your school and city. You're going to tell what's going to happen on Friday, and then you're going to get the forecast for the next 3 days. So you're good. You see yourself. I'm going to go back here, and I'm going to switch it so you guys can see William. Are you ready, William? Remember how to do it? Middle button? Okay, it's all you.
So today we're going to be expecting about 84 degrees as the highest. Thursday it's going to be about 78 degrees as the highest. And 64 is going to be a little chilly on Thursday. For Friday it's going to be 78 degrees as the highest. 68, we're getting pretty chilly. And now we're going to go ahead, let's see. Right now at Cypress it is 69 degrees. It's a little cloudy. The humidity is 87%. We see Wind, we see 5. Visibility 2, it's getting a little bit clear. Futurecast, it's gonna rain on Friday right here. So let's see this. It's gonna rain right here. It's gonna be a really rainy Friday. Look at that. But because of the rain, we're gonna get a really chilly weekend. We're gonna start to get cool, and so we're gonna start to get cool. What to expect? So 84 Wednesday today, 78, 78. So yeah, that's gonna be all. That'll be all.
How'd it go?
All right.
Good job. Okay, who wants to go next? Okay. Okay, I am trying to get rid of the commercial so you guys can see, but you guys are good. So everybody watching is seeing the correct thing except for you guys. But okay, go ahead. Remember to introduce yourself.
Hello, my name is Caden Vach, and I will be presenting your weather today. The high right now, the high today will be 84, and on Thursday tomorrow it will be a little sprinkly with 78 as the high, 64 as the low. On Friday is the day you kind of want to worry about. It will be thunderstorms in the morning and to the afternoon with a high of 78 and a low of 68. Right now in Cyprus, 69 degrees, 87% humidity. Wind is going southeast at 5 miles per hour, and the visibility is 2. Currently right now it is a little bit foggy, but on Friday the storms will move in and there is a cold front. But then after that, it will bring lots of cool air, which will make it nice on the weekend. And yeah, that's pretty much it.
Good job. Excellent. Good job. Okay, our last one is Abilene. We have 2 minutes left in the show. Abilene, you ready to go? You're going to basically end the show. Are you ready? Okay, here comes Abilene. Watch.
Wednesday is gonna be 84 degrees, and Thursday is gonna be 78 and low of 64. Friday is gonna be 78 and low 68. And Cyprus is 69 degrees and it's gonna be cool in today in the afternoon.
Okay, did you say goodbye?
Goodbye.
Awesome. Hey, great job. Come on up. Okay, we have a little less than 2 minutes left. So you guys, first of all, how was that? What was that like?
I don't even know. I was nervous. I couldn't.
All right. What did you think? When you're seeing yourself, what did you feel like?
The feeling of it makes me feel like, it makes me feel a little bit uncomfortable at first, but then when I saw myself actually do it, it felt a little bit more comfortable seeing, you know, what I did.
Yeah. Well, the hardest thing, honestly, the hardest thing about my job when you first start is getting comfortable. It's not what you know, it's getting comfortable doing your job. We have 1 minute left. Abilene, what did you think?
I think it was cool.
It was cool?
I always wanted to be in the camera.
Well, you were on camera, so everybody who watched you got to see you. What you guys will get to see is this is live, but it's also recorded. And so I will send a link to your teachers and your principal. And then if your parents or grandparents missed it today, or your friends, or you want to watch, you can watch later on. So can we say goodbye to our audience? Everybody wave goodbye, wave goodbye.